Okay, welcome. You're here because you want to get smart, fast, on what really matters.
No time wasted.
Exactly, just the core stuff. Today, we're diving deep into oil and gas.
Ah, familiar territory for some, maybe.
Right, but we're looking at it through a pretty radical new lens. This explosion of digital tech and AI.
It's changing everything.
We've got a great stack of info you shared, and our mission here is simple. Boil it down.
Get to the essentials.
Yeah, the crucial takeaways, the surprising bits, and, what it all means for the future of this huge industry, specifically because of digital.
Consider it your quick guide.
Your shortcut to being really clued in on this fast-moving landscape.
Yeah.
So where do we start? The data.
Absolutely. You have to start with data. And the scale is just staggering.
It's not just big data, it's
It's a tsunami. Think about 3D seismic surveys mapping underground in incredible detail.
wow.
Then you've got constant streams from drilling, complex reservoir simulations predicting like decades ahead, and of course, minute-by-minute monitoring from producing wells. It's always been complex, but digital just amplified that data challenge, exponentially.
Okay, drowning in data.
Right.
So what's the actual problem? It's not just storage, is it?
No, not just storage. The real challenge is making sense of it all. How do you actually find the valuable insights in that mountain?
Right.
That's where something called knowledge discovery and data, KDD, comes in.
DDT.
It's a whole process, really. First, figure out your goal, then gather the data, then, crucially, clean it up. Get rid of the noise.
Cleaning is key.
Absolutely. Then you reduce it, apply data mining techniques to spot patterns, and finally you interpret what it all means. It's a pipeline.
Finding that needle in the haystack.
Oh.
Or like a few grains of sand on a massive beach.
Good analogy. And you're right to think a lot of this isn't neat and tidy.
Yeah, I bet it's not all spreadsheets.
Exactly. Think geological reports, logs, often just free text, even video feeds from inspections.
Unstructured data.
Precisely. That's where web mining becomes important, pulling info from that messy stuff. And then to actually connect the dots and let computers reason with it. That's where concepts like the semantic web and knowledge management come in, building a smarter, more connected understanding.
Okay, connecting the dots. You mentioned cleaning data filtering signals. That sounds fundamental. How important is that?
Oh, it's critical. Imagine trying to hear a whisper in a loud room. That's kind of like raw sensor data sometimes, temperature, pressure, whatever.
Allostatic.
Exactly. Data filtering, whether it's analog circuits right there or digital algorithms later, cleans out that static, the noise.
And if you don't?
Well, you risk making bad decisions based on bad data. High stakes in this industry, right?
Absolutely. Okay, so we're getting a handle on the data ocean. Now let's talk intelligence. AI. What are we really aiming for?
Well, simply put, AI is about getting machines to think or act like humans in specific ways. The usual definition is simulating human intelligence processes.
So what aspects of intelligence are key?
Researchers focus on things like learning how machines get new skills from data, reasoning, making logical steps, problem solving,
Right.
perception, like interpreting images or sound, and language understanding, processing human language.
So it's way beyond just basic automation doing the same task over and over.
Definitely. It's about machines that can learn and decide.
Where is this actually happening in oil and gas, not just theory?
Oh, it's practical now. Things like expert systems, they capture experienced engineers' knowledge for, say, troubleshooting.
Okay.
Natural language processing is analyzing maintenance logs, spotting potential issues early. Speech recognition could let workers use systems hands-free, which is great for safety. And machine vision. That's used for automated inspections, finding corrosion or damage humans might miss.
That feels like a big leap. Now, AI and automation people use those terms together a lot. What's the key difference?
Think of traditional automation as replacing, like, human muscle for very specific, repetitive tasks. A valve opens at 9 a.m., closes at 5 p.m. Simple. AI, especially when you combine it with robotics, they call it intelligent robotic process. Automation aims to replace human thinking effort in more complex situations.
So it adapts.
Exactly. The intelligence lets it adapt, learn, make decisions without a human stepping in every single time.
Okay, automation repeats, AI figures things out. And the hardware powering this must be pretty beefy.
Oh, yeah. We're talking powerful multi-core CPUs, but also specialized things like GPUs, graphics processing units, and FPGA.
GPUs. Like for video games.
Same idea. They're incredibly good at the parallel calculations AI needs. FPGAs offer speed and flexibility too. It's interesting, Moore's law.
The doubling thing.
Yeah, that seems to be slowing down. So the industry is shifting to these multi-core setups and specialized chips to keep pushing computational power for AI.
Makes sense. Okay, AI is the big goal. Machine learning sounds like the engine driving it. How does ML work its magic?
Right, ML, machine learning, it's a part of AI. It's where we train computers to learn from data without programming every single rule explicitly.
You feed it data, it learns.
Pretty much. It identifies patterns, makes predictions, or makes decisions based on what it learned from the data. There are a few main types. Supervised learning.
Supervised, like with a teacher.
Exactly. You give the algorithm examples, inputs, and the correct outputs. It learns the mapping. Used for things like predicting rock permeability from well logs, that's regression, or classifying if a sensor reading means fault or no fault.
Okay, so it needs labeled examples, the right answers. What if you don't have those?
Good question. That's where unsupervised learning comes in. The algorithm explores data without labels to find hidden structures itself.
Like finding groups.
Yeah, clustering is common. Grouping similar well performance data, maybe, without knowing why they're similar beforehand. Then there's reinforcement learning.
How does that work?
It's more like learning by trial and error. An agent interacts with an environment, gets rewards for good actions, penalties for bad ones. It learns the best strategy over time. Think about training an AI to control a drilling robot safely and efficiently.
Learning by doing. Very different. And deep learning, that gets a lot of press.
Right. Deep learning is a powerful type of ML, using artificial neural networks with many layers. That's the deep part.
Inspired by the brain.
Loosely, yes. These artificial neural networks, ANNs, have interconnected nodes. They're great for complex stuff like image and speech recognition. A key training method is backpropagation, or BP, which fine-tunes the network.
Okay. Now, earlier we mentioned KDD, knowledge discovery, and here we have data mining with ML. Are they the same thing?
They're very close, often overlap, but there's a slight nuance. ML often focuses more on prediction, using patterns to forecast what will happen.
Okay.
Data mining is maybe more focused on discovering unknown patterns in big data sets, things you didn't even know to look for.
Prediction versus discovery. Subtle that makes sense.
Yeah.
And someone wants to get into this, what tools, what languages?
Python. It's really become the go-to language for AI and ML.
Why Python?
Well, it's relatively easy to learn, readable, and has this huge ecosystem of libraries. NumPy for numbers, SciPy for science, and then specific ML libraries like PyBrain and especially Scikit learn tons of algorithms ready to use.
So Python's the key. Now, you mentioned some real-world examples in the sources. Can we dig into those?
Absolutely. The first one from Trio Labs really highlights that effective ML isn't just about fancy algorithms. It's about tailoring the approach to the business goal, the data you actually have, and your resources.
Practicality matters.
Hugely. Then Mercado Libre, the big e-commerce company, great example of AI efficiency.
What did they do?
They had this massive problem, automatically categorizing millions of new products. They built custom clustering algorithms using neural networks, LSTMs actually, and user navigation data.
And the result?
A 10-fold increase in category creation speed, 5-fold jump in productivity. Huge impact.
Wow, that's incredible. And the third one was more specific to oil and gas well pumps.
Yes, tackling anomaly detection in oil well pumps, predicting failures before they happen. Using ML on the time series data from the pumps, pressure, vibration, temperature, they built a system to identify real alerts, but crucially, cut false alarms by 50%.
Fewer false alarms is big.
Definitely. And what's cool is they added a feedback loop. Human operators reviewed alerts, fed their expertise back in, and that made the ML models even smarter over time. Human-AI collaboration.
That's a fantastic example. Directly impacting operations, reducing costs. Okay, let's shift gears a bit. Talk about the actual physical operations. Distributed control systems, DCS. What are these?
DCS are really the brains, or maybe the nervous system, of modern process plants and drilling rigs. Instead of one giant central computer, you have multiple independent controllers spread out, distributed, all connected by a network. Each handles a specific part of the process.
And operators see it all?
Yeah, through human-machine interfaces, HMIs. They give a consolidated view.
So it's more resilient. If one part fails, the whole thing doesn't stop.
Exactly. That's a major advantage. Before DCS, you had manual control, then pneumatic controllers, then maybe centralized analog electronic systems on big panels. DCS was a huge leap.
What are the main benefits?
Well, handling really complex processes, much better reliability because it's distributed, and faster control because the processing is closer to the equipment.
Got it. I saw Field Bus mentioned too. What's that? How does it connect?
Field bus, like Foundation Field Bus or Profibus, is the digital communication network between the field instruments, sensors, valves, and the DCS.
Instead of individual wires for everything.
Right. Traditionally, every sensor needed its own wire pair back to the control room. Field bus lets multiple devices share one cable, saves massively on wiring, simplifies installation, maintenance.
Less wiring, more data.
And much more data can flow back from those smart instruments, too.
Okay. Now, real-time optimization, RTO. How does that fit with DCS?
RTO is like an intelligent layer sitting on top of the DCS. It uses complex mathematical models of the whole process, plus the live data from the DCS to constantly figure out how to run things better, more economically. Maximize production, cut energy use, improve quality, that kind of thing.
And so it optimizes on the fly.
Yeah, it calculates the best settings and sends those down to the DCS, which then adjusts the process automatically. Often no human needed in that specific loop.
Like an AI co-pilot constantly fine-tuning.
Good way to put it. And of course, with all this digital control, security is vital, right? Threat perception, dependability, absolutely critical. As systems get connected, they become targets. So threat perception is understanding those risks. Dependability is ensuring the system works correctly, even with faults or attacks. You need strategies for prevention, detection, mitigation, the whole package.
Security has to be built in. Okay, we've covered data, AML, core control systems. Let's get specific to the oil field. Intelligent wells and automation. Sounds innovative?
Very much so. Intelligent well technology is all about getting more oil and gas out for longer. The idea is to monitor and, crucially, control the flow inside the wellbore in real time.
How do you do that?
You use downhole sensors for continuous data and then control devices. Things like inflow control devices, ICDs, which are usually passive,
Okay.
and inflow control valves, ICVs, which are actively controlled from the surface. They let you manage flow from different zones in the reservoir.
So you can adjust things deep underground.
Precisely. ICDs help even out the flow along the well. ICVs let you choke back or open up specific zones. There are even autonomous ICVs, AICVs, that can automatically shut off unwanted water or gas without surface commands.
Wow. Autonomous valves. What are the benefits?
Potentially huge: increased production, better ROI, more reliability, and a big one: reducing unwanted water production, which saves a lot of costs and hassle.
That sounds game-changing for well management.
Right.
What about drilling itself? How's digital changing that?
We're seeing a big push towards automation. RPA, robotic process automation, handles repetitive office tasks tied to drilling.
Right, the paperwork.
Yeah, but the real action is automating the drilling process itself. Using sensors, analytics, ML to optimize drilling in real time, steer the bit better, even predict and avoid problems like stuck pipe.
So moving away from purely manual control.
Exactly.
Yeah.
Towards more autonomous, AI-driven drilling and completions for efficiency, safety, precision.
And I saw 4D seismic mentioned. How does that help?
4D seismic adds time to 3D. You shoot seismic surveys over the same field at different times during production.
So you see changes.
Exactly. You see how fluids are moving in the reservoir over time. It gives amazing insight, helps optimize production, and forecasts the well's life much more accurately, like a time-lapse video underground.
That's powerful. Okay, so generating, analyzing all this data, using AI, automating. Where does it all live and get processed? That must bring us to the cloud.
It does. The sheer scale, especially for things like reservoir simulation and seismic processing, is driving cloud adoption. High-performance computing, HPC, in the cloud gives companies massive power on demand.
Makes sense. You need that flexibility. The sources mentioned Schlumberger's DELFI software specifically.
Yes, DELFI is Schlumberger's cloud platform built for E&P exploration and production. It integrates data, science, workflows, all in a secure, collaborative environment. Teams can work together virtually on the same data.
Any examples of the impact?
Oh, yeah. One showed INPEX cutting seismic processing and interpretation time by 80%.
80%.
Dramatic, right, using DLFI's cloud power and ML tools. Another with OMV showed faster well planning and field development, and it's enabling digital drilling too, integrating real-time data with analytics.
Huge time savings.
Uh-huh.
But are there hurdles to cloud adoption? It can't be all smooth sailing.
No, there are challenges. Potential vendor lock-in with one provider. Interoperability between different clouds isn't always seamless yet. And integrating with existing IT systems can be complex.
So what's the solution?
Well, one idea gaining traction is the Reservoir approach, basically a federated cloud where multiple providers cooperate, offers more flexibility, maybe avoids lock-in.
An interesting model. Okay, let's start pulling it all together. Looking at the big picture trends. What's the main takeaway?
The overriding trend is just increasing digitization everywhere. From finding oil to delivering it, digital platforms are becoming business models. AI is predicting future production really accurately with things like type curve analysis.
So the digital oil field is becoming reality.
It's expanding beyond just the field, really, encompassing all operations, moving towards automated oil fields, maybe even automated companies where data just flows and analytics drive decisions.
A fundamental shift. Any
Yeah.
government push is mentioned.
Yeah, in India, policies like HELP and OALP are boosting exploration, and technology like advanced seismic systems is key to making that happen efficiently.
Okay, and finally, looking ahead,
Mm.
any potential disruptors or threat perceptions the industry needs to watch?
Well, the rise of electric vehicles, EVs, is definitely on the radar as batteries get better and governments push for cleaner transport.
Demand for gasoline could change.
It could impact long-term demand for traditional fuels, yes, which really pushes oil and gas companies to innovate, use these digital tools not just for efficiency, but maybe for new business models, diversification,
Right.
staying competitive in a shifting energy world.
So it's adapt, or,
Yeah.
well, adapt. This has been fascinating, really getting under the hood of digital and oil and gas,
Yeah.
the sheer data volumes, the power of AI and ML, the changes across the board. It's huge.
It really is.
For me, that 80% reduction in seismic time was a real aha moment. It just shows the scale of impact. And the idea of intelligent wells, automated operations, that's compelling stuff.
It's definitely a dynamic space. Lots happening, lots changing.
So for everyone listening, here's something to chew on. Given this incredible pace of digital change we've talked about, what do you think the next big game-changer tech will be for oil and gas? What's over the horizon? And how do companies or even individuals stay ahead of that curve? This deep dive is really just scratching the surface.
Hopefully it sparks some further exploration.
Absolutely. Thanks for joining us on the Deep Dive.